Hello friends, in this chapter of electrostatics we are going to studying about vector representation of Coulomb's force. In this lecture we are going to learn regarding the vector representations. So first of all we have to take a figure. There is a figure where there are two charges q1 and q2, and from the origin O the distance of q1 is r1 and distance of q2 is r2. Now if we want to tell any position, there is two charges q1 and q2. Now suppose we have to tell the position of q1 and q2 from the origin, then we will apply the position vector to describe it. Now how we can describe the position vector? To draw a position vector, draw a line from the origin to the given charges. So we will have to draw a line from the O to q1 and for the q2 and name it r1 and r2. We are getting we are giving a arrow on r1 and r2 also. So it represents now the r1 and r2 as a position vector. Now see here r1. What is r1? So we mention here r1 is position of q1 relative to origin. It means from the O it is given a position, so we are defining it by r1. Same as r1, r2. What is r2? r2 is the position of q2 relative to origin O. Now see what is r12 vector. R12 vector means we are giving the position of q1 relative to q2. It means q2 will be the origin for q1, then we will mention r12 position of q1 relative to q2, and r21 vector will be position of q2 relative to q1. Now see the unit vector. What is unit vector? Unit vector only represents the directions. So r12 cap will be the unit vector and that will be direction of r12 vector. Similarly r21 will be the direction of r21 vector. Now we will see regarding the force which will showing in figure F12 and F21. Now q1 and q2 will apply a force on each other. See, both are in same nature, so it will apply a force on each other. That will be the repulsion force. It will go far from each other. Okay, so now F21 vector will be force on charge q2 due to q1. Whatever the q1 will apply any force on q2, that will be known as F21 vector. Similarly F12 vector is the force on charge q1 due to q2. Now note it, whenever we write any vector, so first of all we will have to write its magnitude, then we will write its direction. Okay, so see, we write here F12 and F21 with the formula magnitude and the direction. Now see, F12 is equal to, from the Coulomb's law, force law, F12 vector is equal to k q1 q2 by r square into r12 vector, unit vector. Why we are giving this? Because from the note we see we will have to write magnitude first and then its direction. So here r12 will be the direction and the k q1 q2 by r square will be the magnitude. Similarly F21 will be the KQ1 Q2 by R square into R21. We consider both as first and second equation, but see from the figure R12 and R21 both are in opposite direction. Okay, so we can write it R12 is equal to minus R21 because it is in opposite direction. We can write this. We put the equation, we put the R12 value in equation first, so we will get the new equation, that will the F12 is equal to KQ1 Q2 by R square into minus R21. Now consider it as third equation. So now we can do from equation 2 and 3. Now from 2 and 3, F21 is equal to minus F12 or F12 is equal to minus F21. So we can say this is the formula for the Newton's third law. If we are applying any force on any object, the force will repel with the same value of force to the opposite body. So here we can say that vector representations of Coulomb force will prove the Newton's third law. This is the vector representations of Coulomb force. In this video we discussed regarding the vector representations of Coulomb force. If you like this video, please subscribe our channel and press the bell icon for the upcoming video. Thank you very much.